The table shows the masses of the school bag of 50 students. As you can see, it means the total number is 50, the frequency. A. Find the range of the data. You know, the formula for the range of the data is maximum number subtracted with the minimum number. As you can see, the maximum value of x is 8 and the minimum value is 2. So the range is 8 minus 2 equal to 6. And then B. Construct the cumulative frequency table of the school bags of 50 students. So, as I taught you in the video, this is how to make a cumulative frequency table. You start with the lowest value, this is x less than 2, and then end at the maximum value. So for the minimum value, it start from 0, and then for x less than 3 is 4, as you can see in this table, and then for less than 4 is less than 3 and less than 4. It means the sum of these two numbers, so it's 14, and so on for 27, 30, 44, and 50. Remember, the total frequency is 50, so you have to find 50 at the cumulative frequency table. Next, the cumulative frequency curve shows the speed of cars on a road. So in order to find the value of frequency between 40 and 50, we need to find the frequency of these two numbers. So for the 40, we make a perpendicular line to the curve, drag it to the cumulative frequency axis in this axis, and then you will get 70. That's for 40. How about 50? For 50, still the same way, you make a perpendicular line and you drag it to the cumulative frequency axis. You'll get 100. So x more than 14 less than 50 is 100 minus 70 equal to 30. That's how to find the frequency for x 40 less than 50. For the set of data, this is the set of data as you can see. Find the lower quartile or Q1, median or Q2, and upper quartile of Q3. As I thought in the video before, Q1 is divide the data in two parts equally. This is Q2. And then Q1 is divide the first half of data equally, and Q3 divide the second half of the data equally. So this is Q1, Q2, and Q3. Q2 is obviously 59, as you can see here. But for the value of Q1 and Q3, Q1 is between 28 and 34. It means you need to find the average between 28 and 34. You add those numbers together and divide it by 2, you will get 31. And so with Q3, you find Q3 in average of 73 and 83. You add this number together and divide by 2, you'll get 78. And then for the same set of data, find the interquartile range of the data. As we have found before, Q1 equal to 31 and Q3 equal to 78. So the interquartile range is Q3 minus Q1 equal to 78 minus 31. So the IQR or the interquartile range is 47. Find the lower quartiles Q1, median, Q2, and upper quartile Q3 from the curve. As you can see, this is the curve that we're going to work with. So for Q1, the formula is a quarter of n, 1 per 4 times n. N is the total frequency. As you can see, the highest value of frequency is 100. So n equal to 100. So 1 per 4 times 100 equal to 25 or 25th data. Q1 is the 25th data. 25th is around here. You make a line to the curve and you drag it down, and this is the value of Q1. So Q1 equal to 19. And how to find Q2? Q2 is a half times n. N is still 100. So a half of 100 equal to 50 or 50th data. So the 50th data is here. You drag it here and drag it down, and you will get the value of Q2 equal to 32. And next, how to find Q3? Q3 is 3 per 4 times n. 3 per 4 times 100 equal to 75th. So the 75th is around here. You make a line to the curve and then make a line to this axis. So the value of Q3 is 42. That's how you find Q3. And then let's move on to standard deviation. Find the standard deviation of the data 1, 2, 3, 4, and 5. As you can see, the data is ungrouped. So the first thing that we need to identify is how many data are in here. So the data is only 5. There are 5 numbers here. And then we're going to find the sigma of x. Sigma of x is total of all these numbers, all the data. So 1 plus 2 plus 3 plus 4 plus 5 equal to 15. Next, we need to find the sigma of x square. So the total of square of each data equal to 55. And then the formula for standard deviation for ungrouped data is square root of sigma x squared per n subtracted by square of sigma x per n. We have found every single number in this formula. It's 55 per 5 minus 15 per 5 square. We know that 55 per 5 is equal to 11, and 15 divide 5 is 3, and 3 square is 9. So 11 minus 9 equal to square root of 2. This is standard deviation for this data. And then still standard deviation, but find the standard deviation of the data below. The data served in a table. It means the data in a group. So we're gonna use the formula for standard deviation for grouped data. Remember, the first step to solve a standard deviation in group data, we need to add 3 more columns. The columns are the column for fx, and then the column for x squared, and the last one is the column of fx squared. So fx, how can we get these numbers? These numbers comes from f times x. So for this number 0, it comes from 0 times 5. The x is 0 and the x is 5. So 0 times 5 equal to 0. And this number comes from 6 times 20. 6 is the f and 20 is the x. And so this number, and this number, f times x. And then this number is x squared. You just need to square each and every single numbers in this column. 25 comes from 5 square, 400 comes from 20 square, and so on, 40 square, 60 square, and 80 square, and you will get these numbers. And then these numbers comes from f times x squared. This is the f, this is the x squared. So 0, it comes from 0 times 25. 2400 come from 6 times 400. 14,400 comes from 9 times 1,600. And these numbers come from 10 times 3,600, and 32,000 comes from 5 times 6,400. This is come from f times x squared. Okay, and then we need to find some sigma. First, sigma of f is a total of f. You add all these numbers together, you will get 30. Sigma of x squared, you find the total of all these numbers in this column, you will get 1,480. And then sigma of fx squared is from this column. You add these numbers together, you will get 84,800. Remember, the formula for standard deviation for group data is, this is the formula. So square root of sigma fx squared per sigma f subtracted by square of sigma fx per sigma f. Standard deviation equal to we have found all the numbers that we need. It's 84,800 per 30 subtracted with square root of 1,480 per 30. We make the numbers in the same denominator, it's 9, and we'll get the standard deviation equal to square root of 3,536 per 9.